Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
Are you a Form 2 or Form 3 or Form 4 students who is looking at online schools where you can learn, understand, enjoy, and apply the beauty of mathematics? That's a question that you possibly might be asking yourself for a long time. How are you, everybody who is watching this video? If you've been asking questions like that or some other questions related to that, I would like to take this opportunity to welcome you to the home of the answers of many questions of students who want to learn and enjoy the beauty of basic mathematics. My name is Olenjolai&Nekinyi. Simply just call me Olenjolai. I thank God by His own grace, He has called me to be His teacher, His national and international teacher. So God built in a gift of teaching. And what am I going to teach you? That is the questions you have in your mind. I'm going to teach you about the beauty of basic mathematics for ordinary secondary education, and also I'm going to teach you the beauty of physics and the beauty of chemistry for ordinary secondary education from 1 to Form 4 by using the syllabus and curriculum of United Republic of Tanzania. I would like to take this opportunity to welcome all the national and international viewers. You are warmly welcome into our online school where you can learn, enjoy, and understand and apply the information that we are going to teach you, because the subject we are teaching are multinational subjects, just we call them. It means every nation, in every nations where they are using English or they're using maybe some other national languages, but they're using English at the learning process, or even those that are using French, they are learning about basic mathematics. In terms of Cambridge system, this is equivalent to, because in Tanzania we have Form 1, Form 2, Form 3, Form 4, 4 years. Those are the time, appointed time for ordinary secondary education in Tanzania. Again, for the international students, this is equivalent to what you've been receiving in grade 8, grade 9, grade 10, and grade 11. So whether you're national or international students, you're warmly welcome, and take a seat and concentrate and focus on the information that I'm going to share with you. Firstly, I would like to take this opportunity to welcome all national and international viewers. If it's your first time, or if it's your second time or third time, so you are permanent students of the also, I would like to take this opportunity to welcome once again into this fantastic and new session for you into our online school that called Tanzania Online Ordinary Secondary School in Square Bracket Olenjolai. Simultaneously, I would like to welcome you into one of our official YouTube channel. This is one of the international, multinational, just to call it online American video sharing system. That is called Tanzania Online O-Level Secondary School in Square Bracket Olenjolai. Wow, I know you have so many questions. And I would like to tell you that even ourselves, we have so many answers that will answer your questions, regardless of how your questions are difficult, as long as it's relating on focusing on vision, purpose, and even also the beauty of mathematics and science. Then I would like to tell you in advance, we have a good news for all lovers of mathematics and all lovers of science. So you're asking yourself so many questions. One of the questions that might be coming in your mind, why do you need to be a student of Tanzania Online Ordinary Secondary School in Square Bracket Olenjolai? That's a very good question. We are here in order to train and teach on our ordinary secondary students online by using the power of the internet on how you can extract knowledge, understanding, and wisdom from the classroom instruction to combine it with knowledge, understanding, and wisdom from the Word of God written in the Holy Bible in order to solve real life problems. We know that in the mind of most students, even my mind also, when I was a student, before I was encountered or I was in a touch with vision that God has put in my heart, I was focusing on preparing myself on make sure to understand basic mathematics, physics, chemistry, the other subjects in order for me to pass all the continuous assessment exams, to pass the midterm testing, to pass the annual exam, to pass the terminal exams and different exams. For example, for the Form 2, I know that you are asking yourself how I can have a good continuous assessment. Well, those are the specific objective of TOESL. Those are the specific objective of online ordinary secondary school. But the main purpose or the main objective is to teach our students to think outside of the classroom on how to use the information that will be gathering from session to session, topic to topic, subject to subject, in order to solve real life problems. But again, we have another specific objective which possibly it's troubling in your mind. We like to prepare our secondary students, ordinary secondary students, in order to answer the national exams that prepared by the National Council of Tanzania, the National Council of Examinations in Tanzania. So we call it in short NACT, National Council of Tanzania, National Councils of Examinations in Tanzania, right? That's the meanings of the just abbreviations of NECTA exam. But also for those who are international students, we are preparing you to answer and tackle different questions from your examination system, your examination type. So you have to stay tuned. Those are the specific objectives. But the main objective, after you have understood that information, we teach you how to think outside the class and focus on the real life problems. Thirdly, I would like to take this opportunity to take you into the simplest journey of registration into TOESL. If you have never registered yourself, you're warmly welcome to follow this system. If you have registered yourself, I would like to ask you to just listen these informations in order to share with other students who are not registered in TOESL, because this registrations process is one lifetime registrations. It's guaranteed, and also I would like just to tell you that you'll never be discouraged. The first step, if you have an email, then skip the first step. But if you don't have, we ask you to create or open a new email. So what the meaning of email? Email is an address that can help you to communicate online. Communicate online, to send the information and receive the information. That's all, the simple meaning. Again, we ask you that to have the YouTube application. Okay, I trust that you have it in your mobile phone, so in your computer. If you don't have, you can download it. And then the second step that I assume, that assumption that I've made. The second step, we ask you that to sign in. So after you have created it or opened a new email, we ask you to sign in YouTube by using your email. The email that you have created, you have to remember your username and password. Write it somewhere in the secret place, and don't share your password and username to anybody else, because these are confidential information. The third step, after you've signed in, we ask you now, sign in YouTube. You're already in YouTube, so mean that you have your unique identifications, which is your email in YouTube. We ask you to search what? To search TOESL. TOESL, don't search TOESL. Simply copy and paste this name, Tanzania Online O-Level Seki School, in square bracket Olenjolai. So that abbreviations of TOESL, Tanzania Online Ordinary Secondary School, in square bracket Olenjolai. Search TOESL in YouTube. After you search it, you see TOESL's poster. This we call it TOESL's poster, which contains Tanzania national flag. So I'm a Tanzanian. I'm doing this program for the Tanzanian students of present and future generation. This is our national flag. And as you'll see our national flag there, right? And then below it, you will see some of the, we call the homes. Okay, so we have what the videos. You see the horizontal tabs. You have playlist, right? Playlist. So later on, I'll navigate you into this part. Right now, we ask you that click click the round button. So click this round button only once, right? Round button, right? Round button of 40 that contains Tanzania national flag, right? Once you click it, you're already in our online school. Then you'll see a button that called or just it means a button written subscribe. So he asks you to click it once. Click the buttons written subscribe. It has a ready background color, okay? And then the text is subscribe in white color. So once you click it, the text will change into subscribing. And once you do that, the icon of the bell will appear on the right hand side of it. We ask you to click this icon of the bell. You'll see 3 options. Choose the options of all. From there, you have already registered yourself permanently. Right now, you will get notifications whenever we add a new video. And you have a good news that we have a vision to record more than 600 high definitions and high quality videos that will teach you 12 subjects of ordinary secondary education, or just we call it middle school, in order for you to master this subject and enjoy them for the rest of your life. So from now, I ask you to make sure that you regularly visit online in order to get updates from us. Again, in order for you to access our contents, we'd like also to just come back into the top horizontal toolbar, and hence we ask you to click the icons written playlist, right? Playlist. So click the text or just the horizontal toolbar or just the buttons, software buttons. Click the playlist, and then you can search the playlist written exponents, and radicals. So there you will see a collection of all sessions from first session to the last session of of radicals and the exponential, or radicals and exponents. Wonderful. So then you can click also the icons, you can like, you can share, you can ask a question in the comment sections in order to interact with me. You can do a lot of things online. So I'm not physically with you. You see me, possibly I don't see you, but don't worry about that. I expect so many questions from my students. Wonderful, okay? So in case you have any questions along this session, I ask you to ask in the comment section of this session, right? All right, so let us go into today's session. So today, I would like to welcome you into the departments of Basic Mathematics, 34. And we have a subject called Basic Mathematics. These contents are for the pre-Form 2 or grade 9, Form 2, QT, reciters, teachers, diploma, and regular students can use these contents. Wonderful. So we are in chapter 1 that called Exponents and Radicals. We have 11 chapters for Basic Mathematics in Form 2. Pre-Form 2, you won't be welcome. Form 2, you won't be also welcome. QT, you won't be welcome. Okay, so then we are in second subtopic. We are done with the first subtopic, and we taught you 9 sessions from session 00 to session 8. That is called the exponents. Today, I would like to introduce to you the new subtopic, which is subtopic 2, that's called radicals. And this is session 9. And the session 9, I have given it a title, What is Radical? So from the beginning to the end of this session, I will build in your mind the concepts of radical. However, that the concepts of radical is not new. We taught you in primary education, but I know 75% of Form 2 secondary students in Tanzania learned the concepts of radical by using the Swahili language during the primary education. So possibly 25%, they covered this concept in English. So for those who are, for both, whether you are, regardless whether you are come from English primary medium or secondary or English primary medium or Swahili primary medium, listen careful. I'm going to teach you something which is new for both educational system that you are originating. So I'm going to add a value, right? So are you ready? Let us go into the session. The fundamental question, there's no need for quick review because that's all about the exponential. Okay. The fundamental question, so it means that today I'm going to teach about the concept called the radicals or radical. The fundamental question that you have, which is called the question 1 for this session, what is radical expression? What is the meaning? What is the meaning of what? Of a radical expression, radical expression in mathematics. That's the question that we have in mathematics. Okay? There are so many definitions, but I chose this one. A radical expression. So a radical expression, because you have expression and equation. A radical expression, okay, radical expression, we say that is the any mathematical expression. Is the any mathematical expression that contains what? That contains the symbol, of what? Of radical, symbol of radical, which is what? This one. That the simple definitions of what? Of radical. What is radical, ladies and gentlemen? Ask your neighbor, pause the video and ask yourself. Radical expression is an expression containing a radical symbol or a symbol of radical. But some other references also define the concepts of radical, that or radical expression is opposite expression. So this is the opposite expression to the exponential expression. So that's why there's a close relationship between radical and the exponential expression. Okay? So it means that the point you have to remember is there is close relationship. There's a close relationship between radical and there's a close relationship between radical and exponent. Right? An exponent. So how do we generate radicals? Where does the concept of radical come from? Listen carefully. This is the point and this is the answer. So, okay. So you say that when a number, when we find the meaning, the symbol of radical, when a number is expressed, so this is another point that you have to note, when a number is expressed, as a product of what? Of equal factors. Product of equal factors. Each of the factors is called the root of that number. Each of the factor is called the root of a number. So when a number is expressed as the product of equal factors, so we taught you the concepts of factor in the first topic of Form 1 in basic mathematics, that's called the numbers, which we taught you in 2 languages. In case you missed it, got the playlist of numbers, and then you'll access all the sessions, or you access the session, which is session 13 and session 14, which is all about 20 factors of a number, right? So each of the factors is called the root of 14 of a number. So Here we are still discussing the concept of what? Of radical. So the concept of radical, we have also something we call the root. So we have radical, that's one of the vocabulary, and hence we have another vocabulary, root. Radical, sign, simply we are focused on the sign, but we have something called the root, which is later on we call it the index. Okay? Yes, stay connected. Let me clarify with examples this sentence. When a number is expressed as a product of equal factors, a number can be expressed with a product of non-equal factors, right? Non-equal factors. So for that ones, we cannot say that each factor is a root. But each factor is a root if and only if a number can be expressed in equal factors. What does it mean? Examples. So for example, let us take the simplest number, that is 4. 4, we can express the 4 in expanded form, which is 2 times 2. This is product of 2 equal factors. So also we can express this one in exponent. This is exponential. This is the power form, or this is the number, or this is the number, and this is the expanded form. So in exponential form, this is 2 power 2, right? All right. According to this sentence, that when a number 4 is expressed as the product of equal factors, so 2 and 2 is a factor. So from this one, we say that 2, either this 2 or this one is what? Is a root of what? Of a number. A root of a number. What the number here? A root of 4. All right. Again, we can have also another number. So let us think about number 9. Number 9, it can be expressed as the equal factors of 3 times 3. In exponential form, this is 3 squared, right? Exponential form. But in expanded form, 9 times 3 times 3 times 3, this is the products of equal factors. So 3 is what? Is the root of what? Is the root of what? Is the root of 9. Right? Is the root of 9. Okay? Again, another example. Okay, so right now we have, let's say, a number. Let us take a little bit, a large number. 3. What? 27. 27, we can express 27 as a factor of what? 9 times 3. That is the product of what? Unequal factors. 9 is not equal to 3. But also we can express 27 as the product of what? 3 equal factors. So this is a factor, this is the factor, this is the factor. So this of 3 also, so I say that number 3 is the root of 40 of 27. That's the meaning of that sentence. Okay? Bear that in your mind. Again, so we are developing the concepts of radical in our mind so that because you should not forget this concept until you do your PhD. Even the computer systems that you are using, even the smartphones that you are using, the iPhones that you are using, there is the concepts of radical more than you think. Okay, so that's one of the concepts. So you say that we have something that we call the square root. Okay, yeah. So I think that one as well. Okay, yeah. So you say that again. This is what you have to know. Not if a number has only 2 or has what? Has 2. If a number has 2 equal factors, then the factor, that factor in mathematics is called what? Is called the square root. Square root of a number. Square root of a number. That means of what? Of square root. We are still teaching the concepts of root. We'll come back later into the concepts of what radical sign. If a number has two equal factors, then the factor is called the square root of a number. So let me give you examples. Example, we have what? So we have 16. 16, this is 4 times 4. For that case, 4 is the square root. 4 is the square root of what? The square root of 16. Right? Square root of 50 or 40 of 16. So this is one of example. Second example. For example, also we have what? For example, we have 49. 49, it can be expressed as 7 times 7, products of two equal factors. So 7 is the square. 7 is the square root. Is the square root of what? Of 49. Okay? The square root of 40 of 49. Again, another point that we say, if a number has three equal factors, then the factor in mathematics, the factor is called what? It's called the cube root. Cube root of 40 of a number. Cube root of a number. Okay? If a number has three equal factors, then the factor is called the cube root of 40 of a number. So let me give you a few examples. Example, 27, this is equal to 3 times 3 times 3. So 3 is called what? Is called the cube root of what? Cube root of 27. Cube root of 27. Cube root of 40 of 27. Okay? So it's called the cube root of a number. Then, another example, we can have, let's say, 125. This is equal to 5 times 5 times 5. 3 equal factors, products of 3 equal factors. So 5 is a cube root of what? 125. That's a concept. Similarly, if a number has 4 equal factors, in mathematics we call it fourth root. Again, if a number has 5 equal roots, then the factor is called the fifth root of a number. If a number has 6 equal factors, then the factor is called the sixth root of what? Of a number. Etc., etc., etc. Similarly, in terms of what? Of letters. Okay? So let me say similarly, the same concept. Similarly. Okay, similarly, if you have m squared, okay, m squared, this is in expanded form, it is m times m. So simply in exponential it is m squared. So simply say that m is a square root. M is a square root in terms of letters, because a number can be represented by a letter. So m squared is the square root of 40 of m squared, right? Again, I'm not introducing, I'm still dealing with exponents, a number, exponents, and the square root, and the root, something called the root. If also we have, let's say, n cubic. This is n times n times n, if n is equal to a certain number, right? So we say that n, because it is a product of 3 equal n, then we say that n is what? is the cube, n is the cube root, n is the cube root of what? N the cube root of n cubic. Then here we are. Okay? So we say that we have what? We have P, or we have what? We have Q, or Q power 4. So simply say that Q is what? Is the fourth root of what? Fourth root of Q power 4, etc., etc., etc. That's the concept that I wanted you to understand. If you have any question, don't hesitate to ask me in the comment section below of this video. Okay, so if that's the case, until now, I've given you definitions of radical expression. I didn't write any radical expressions. I'll give you examples of radical expression. And then radical expressions, yes, I'll give. I think that right now, let me give you, but before I give you that ones, let me teach you about the radical symbol. Okay? If you have any question about root, ask me in the comment section, please. Root, we call it, okay, so ladies and gentlemen, kipeo, root in Swahili we call it kipeo cha pili. Kipeo cha pili. So let me teach you about radical symbol. So if that's the case, that we can express a number in exponential form. So the question right now that you have also, if that's the case, we can also express a number in radical form. So you have radical symbol. Okay, radical symbol. So you say that radical symbol, which you call it the symbol of the nth root. Okay, because this is just a continuous. Or in other words, you call it the symbol of nth root. Nth root. Symbol of what? Of nth root. Okay. So we have this sentence. Let me just write this sentence. The general symbol used for expressing symbol used for expressing the nth root, of a number, expressing the nth root of what? Of a number. The general symbol used to express the nth root of a number or letter, number or letter, is this one. And here we have n. Okay? So comma, whereby this symbol is called the radical sign. So this is radical sign. And so this is radical sign. And the n is index. Is index of what? N is the index. Is index of what? Yes, is index of a radical. Is index of a number. Is index of what? Of a number, or exponent of the number, by the meaning. So that's the full step. What does it mean? The radical symbol, we say that simply it means that the radical expression now, the general form of radical, the general form of what? Of radical, form of radical expression is this one. So here we have what? Index. This is called just, we put index, And here we are looking the radical of a number or letter in most cases, or expression. Theta or radical 40, or can be expression. Can have different issues there. So this is the general symbol. So you have index. Index is very important. So we have what is, so there we say that this is the general form of 40 of radical expression in mathematics, in science, and even some other aspects of 40, or in some related mathematical form or concepts, okay? So we say that what the index, so it means that in index, it's a power of the number. It's exponent of a number. So remember that index is exponent of 40 of a number. So listen carefully. Listen carefully. From the concept of exponent, we gave you some examples. Should you remember? We took a simple example of what? Of form. In exponent form, it is 2 times 2. So in exponential, it is 2 squared. So in radical, for example, if you want to express 4 in radical, we say that 4. So if you are looking at the radical 4, so we say that here 2 is a square root. So this is index. So remember that. So for example, if you have 4 is equal to 2 squared. So remember, this is 10 for index, and this is 10 for base, and this is 10 for what? For a number, right? So for radical, we say that means this is index, right? Index, here we have an index, and here we have a number, and the response is equal to what? To base. Base, right? So, for instance, if you are looking square root of what? Square root of 4. The answer is equal to 2. Remember, in exponential form, 4 standing in the positions of number, 2 standing in the positions of index, and 2 standing in the positions of base. So in exponential form, this is a number, this is the index or exponent, this is base. You have to listen carefully. Okay? So it means that for square root, you say that if when the index is 2, the symbol represents the square root. When the index is 2, the symbol represents what? Represent square root. Say with me, square root. Square root. Okay, so it means that when the index, when you have this, you have any number or any letter or any expression, then you have 2. Okay? Representing what? Square root of 40 of a number. Right? That's the first point that you have to note. And then we say that normally, so we say that normally the square root, okay, the square root of a number or letter or expression is written without index, but without index, but other nth root without index. But other nth root should be written with the index. It's only the square root because it's universal. What does it mean? For example, if I want to write So the meaning of this sentence, of the previous sentence, the square root of 16 is similar if just I write this radical sign and then I put the number is 16. That's the meaning. For example, if I'm looking the square root of x square, right, and I put 2, this is equivalent if I say that I have square root of x squared. Even if that I'm looking maybe the square root of an expression of x plus 2, this is similarly if I say that the square root of 40 of x plus 2. That's the concept that you have to remember, that on the index which is not shown in most cases is only when the index is 2. But when the index is not 2, the index has to be shown. So we say that all other nth root, all other indices, or in other words, we call it nth root, it means any value of root. Okay, all other indices or nth root are written with the here radical all other indices are written with the value of index. What does it mean? I'm still building the concept in your mind. So only the radical expressions is written without showing its index when the value of index is 2. So simply we say that when index is equal to 2, as we say. So we just write the square root of what? Of 16. But when index is equal to 3, then we have to write it. Okay. So when the index is equal to 2, we write the square root of 16 we don't show the index. When the index is 3, then we have to show the index in the radical sign. When index is more than 3, it means it's equal, when index is greater than 2, or even fractions, then we have to show it is index. For example, when index is equal to what? Is equal to 7. And then the same number, then we write what? 7 root of what? Of 16, etc., etc. Right? So that's the case. But when we have, even if in terms of expression or in terms of letter, okay, if we are looking the 4th root of what? Of x, then you write, right? Or if you are looking the 5th root of an expression, certain expression, 5th root of y minus x cubic, you have to write the value of index. We have the radical sign and the value of index, and this is the expression, right? So from there, right now, I can give you examples of what? Of radical. So examples of radical. So what are the examples of radicals? Because now you understand, example of radical, it can be square root of 17, it can be cube root of x squared, it can be nth root of 34, right? It can be 5th root of what? 5th root of 500. It can be what? It can be fourth root of what? Fourth root of x plus 1. It can be fourth root of x minus 2, x minus 2, like this, etc., etc. So a radical expression is written by using the radical sign and what is and the index. When the index is not shown, that means it's the square root of a number or letter or expression. Do you have any question about radical sign? Because there have been teaching about the symbol of radical and the relationship between the symbol of radical and the nth root. So remember this, not, right? Not. Root, the word root is equal to, the word root is equal to the word index. And this also is equal to the word exponent. These are the same words. Okay? So in case you have any question about radical sign, you have any question about root of a number or letter or expression, ask me in the comment section, please. Ask me in the comment section, please. If you don't have any question, then allow me to teach you relationship between radical and the exponent. Relationship between what? Relationship between radical and the exponents. Relationship between radical or between radicals and exponents. These can be expression, can be questions, but simply we want to see the relationship because I have said that there's a close relationship between radicals and exponents. And that's why that we taught you the concepts of exponents, and next we teach you the concepts of radical. Okay? You say that exponent, simple sentence, exponent of a number can be expressed in, exponent of a number can be expressed in form of radical. In form of radical. Exponent of a number can be expressed in form of radical and what? Vice versa. So exponent of a number can be expressed in form of radical and vice versa. Exponent of a number can be expressed in form of radical and vice versa. And vice versa. That's the concept that you have to remember. Okay? How can we show this relationship? For example, exponential form of a number or expression of a number or letter or expression is this, that we have, this is the general form. We have a number is equal to what? Base power index. power index. But the general form. A number can be expressed in exponent by using that rule. Also exponent, also a number can be expressed in radical by using the same form. So remember that the exponential form is number is equal to what? Base power index. So now in radical form, so I say that in radical form, we have radical sign, and here we have index of a number is equal to what? Base. So this is how radical relate with what? With exponent. So an expression of, or exponential expression, or exponent of a number or letter or expression has three main parts: a number or letter or expression, and then the second part is base of a number, and the third part is index. Similarly, a radical, it has simply four parts: the index, the radical sign, the number, and the base. Okay? And the base. But even this one also is exponent, so it has four parts: number, base, index, and exponent. Here you have what? Number, base, index, and radical. This is the exponential form, and this is the radical form. So that is. So if you've been asked to, if you'll be given exponential expression, and then you have to change it into radical, that's very simple. How? So remember the exponential form is what? Number is equal to what? Base power index in radical form. So in radical form, we have what? We have what? So in radical form, so if you want to convert this in radical form, so you have what? You have radical of a number, you have a radical 40 of a number, and here we have what? Index. Means you have index. And this is equal to what? Is equal to base. That is. Vice versa. So if you'll be given a radical expression, and then be asked, or you need to convert it into an exponent. Then the radical expressions, you know, it's general form. Here you have index. Here you have what? Index. Index of what? Here you have number. And this is equal to what? Base. Okay? The expression exponent, you're going to have what? Number is equal to what? Base power index. So I've been speaking by using words and what? Words, mathematical symbols. Let me use simple examples, because this is the concept we've been dealing with since your primary education. Let me give you some simple examples to demonstrate this concept of relationship between radical and exponents. So let's say that this is exponential form, and this is radical form. So for example, we have 4 squared, that's exponential form, and then in radical form, we have square root of 4. Okay? For example, you can have an exponential expression that is 7 cubic. In radical form, this is index, this is, remember, okay, 3 power 7. Wait a moment. We need a number. No, this is wrong. So let's express in this equation, in the form of the equation. We have 16 is equal to 4 power 2. So in radical form, we mean that, so remember the formula, number, base, index. So in radical form, we have what our index is 2. We should not write it. And then what? Okay. So what the number? Number is 16. Is equal to the base. What the base is 4. Okay. Then we can have what? Example 27. 27 is equal to 3 squared. 3 cubic. Okay, 3 cubic. So simply say that cube root of 27 is equal to what? Is equal to 3. Okay. Again, we can have what? 625. This is equal to 5 power 4. So you can say that the fourth root of 625 is equal to what? 5. Means 5 times 5, 25, times 5, 125, 125 times 5 is 625. Then this is what? Roman 4. Roman 4, wonderful. So you can have maybe a letter, right? So you can have, let's say, x cubed. X cubic. So x cubic is equal to a certain expression. So this one we cannot express not in radical form. Unless that we say, let's say for example x cubic, it's a equation, so exponential equation. So x cubic, let's say, is equal to 4. Right? So x cubic is equal to what? To 4. So if x cubic is equal to 4, then we say that this is number, base, exponent. So we say that the cube root of 4 is equal to what? X. The fifth example, we have x power or x plus 2, let's say power 3 is equal to 20. So this is number, base, index. So what the index? 3. To say that the cube root of a number, which is what? 20, is equal to base, which is x plus what? Plus 2. So this is the relationship between radicals and what? But radicals exponential form and what? And radicals. But that is in form of what? Of the equation. The relationship between what? Between radicals and the between radicals expression and what? Radicals expressions and the exponential expression. So say that there is relationship between radical expression and exponential expression. Exponential expression. What the meaning of this sentence? The radical, for example, exponential means that generally we say that the nth root of a number, this radical form, is equal to a number power 1 over n. What does it mean? Index of a number, this is equal to what? A number power what? Power 1 over index. Power 1 over what? Over index. That's the concept. So, example. If I have square root of 4 in exponential form, this is number, this is index. So in exponential form, this is 4 power 1 over 2. Because 4 power 1 over 2 is equal to 2. And the square root of 4 is equal to 2. So these are the equivalent expression. If you are looking the cube root of 27, this is equal to what? This is equal to 3, or this is equal to what? 27 power what? Power 1 over index, which is 3. Okay? Let me give you more examples. I want you to understand. Do you understand what am I teaching you? So right now, I'm teaching you how you can change the fractional, we got the fractional exponents into radical. This is the whole number or integer exponents. This is the process of converting integer exponent into radical form. And this is the process of converting fractional exponent, which we taught you in previous session, into radicals, right? So remember that. So remember, this expression is equal to this expression, and this expression is equal to this expression. So, if, for example, you'll be given x plus 2, or let's say you'll be given x power 4, x power 4, okay? Okay, I don't want to confuse you. If you'll be given, for example, x power 1 over 4. So in radical form, this is 4th root of x. If you'll be given x plus 2 power 1 over 5. This is equal to 5th root of 40 x plus 2. You have to watch this video several times as well as you can until these concepts are built in your mind, because I'm trying to teach you how you have to think differently and take the concepts of radicals and exponents into your own. I want it to be built in your mind for the rest of your life. So, Roman 5. If you have maybe 3 power 1 over 6, this is equal in radical form. So remember, this is the exponential form, radical form, exponential form, radical form, exponential form, radical form. So this is equal to 6 root of what? Of 3. Or maybe 30. So if you have 30 power 1 over 6, so that's the 6th root of 40 of 30. Okay? Similarly, if you have, let's say, 21 power 1 over n, this is equal to nth root of 40 of 21. Right? Nth root of 40 of 21, etc., etc., etc. So, you may see that the exponential form of equation can be converted into radical form of equation. And exponential form expression can be converted into radical expression. So exponential expressions can be converted into radical expression, and radical expressions can be converted into exponential expression. Radical equation can be converted into exponential equation, and vice versa. So bear that in your mind because we are going to use it in most cases. All right? So that's how we relate exponent and dot and radical. It's very simple. It's not difficult. You have just to remember it and you have to deal with it. And I'm going to do so many examples in order to help you understand the concept that I've been teaching you in this session. So that's how we relate to exponent and dot and radical. Just to give you more examples. For example, if you are looking 169 power 2, this is equal to square root of 40, 169. If you are looking maybe what? You'll be given an expression of what? Of 625 power what? Power 4, power 1 over 4. This is equal to what? Fourth root of what? Of 625. So that the close relationship, so remember the general form, which I gave you, and this is very important. Remember this formula we're going to use in most cases of this session. Okay? So relationship between what? Exponent and the radical and the radical expression and exponential and exponent. Here you have relationship between what? These are the examples. The radical expression and the exponential expressions. Okay? So I love some few examples because I don't want to teach you another concept while I'm still building the concept in your mind. Okay. So let me do one example, which is example 35, and you have to refer this book called the Secondary Basic Mathematics Book 2, Secondary Basic Mathematics. Okay. So when I was reviewing exercise 1.2 and 1.3, I saw this question. And this is the question relating on what? On the relationship, which testing your understanding about relationship between radical expression and exponential expression. So you have to listen carefully because these are the questions you have to challenge yourself. So I would like to point question 1C, which is the questions in example 35, to be homework 2. Homework what? Homework 9. So homework 9. You have to do it. So ladies and gentlemen, remember that you are allowed to pause the video and try to solve these questions yourself. The question asks you that write each of the following in powerful, or the means of powerful. So let us follow some few steps. The first step, we say that the power form is given as this. It depends, the power form of expression, because those are radical. So these are radical expressions. So according to the questions you've been asked, you've been given radical expressions, and you have to write what? Exponential expression, right? So the power form of exponential, so exponential expression, the power form of exponential expression is given as what? So this is given as base power index, right? At the power form of what? Exponential expression. Okay? So the second step. So the second step, we say that in radical of 12, say that 12 is what? 12 is base. But remember the index here is what? Fractional index. Fractional what? Index. So 12 is base. And then 1 over 2 is what? Is index. The questions is testing about what? Your understanding. Just remember this formula. Then asking power form. So this is radical form, this is power form. So you may write this one. This is radical form. And this is what? Power form. That is simple like that. So it means that we say we call what? N's root of what? N's root of a number is equal to what? Is equal to a number power what? Power 1 over index over n. That is simple. So to solve question 1, you have just to call the formula below. So remember that we say index, then you have what? Radical of what? Of a number. This is equal to what? Is equal to a number power 1 over index. So from an A, radical of 12, this is equal to what? Square root of 12, and this is equal to what? 12 power 1 over 2. So therefore, radical of 12 is equal to 12 power 1 over 2. And the answer of question 1, 1A. Similarly for B, B will be given what? Radical of the fraction number, which is 1 over 8. This is the number, but remember this is 2. So this is equal to what? Square root of 1 over 8 in power form. Our number is 1 over 8, and then our index is 1 over 2. Therefore, the power form of what is square root of 1 over 8 is what? 1 over 8 power half. The response. So, Roman C, that is homework 9. Ladies and gentlemen, this is the end of 40 session. This is the end of session 9. What's radical? To summarize, in these sessions I've been transforming your understanding of radical and exponents, and I taught you how do they relate, exponent and radicals. So if you didn't understand any point, please ask questions in the comment section. But you can access this content at any time, anywhere. So I ask you, every student, to watch this video several times until these concepts build in your mind. Because in the next sessions of radicals, I'll be teaching you how you have to relate exponents and and radicals. So ladies and gentlemen, this is the end of session 9. I thank God who have created me in his own image and likeness. I would like to invite you in the next session, which is session 10. I ask you again to subscribe if you didn't subscribe. And I would like to ask you also to invite some other students by sharing the link of this video and the link of this channel to other students through any social media. Again, in case you feel from your heart that you want to offer your free incense giving in order to support the running cost for this program, in order for more than 600 videos of basic mathematics from 1 to Form 4, or grade 8 to grade 11, physics from 1 to Form 4, or grade 8 to grade 11, or chemistry and chemistry, so different sessions of of chemistry from 1 to Form 4, or grade 8 to grade 11, to be in air in order to teach and train ordinary secondary educations of present and future generations anywhere at any time. Don't hesitate yourself to offer your free incense giving to God through this telephone number 0759745331. We'd like to receive your free incense giving with hands of sense. May God bless you abundantly, and thank you for being part of the also. And I would like to invite you in the next sessions, which is session 10, when I will teach you about how you can find the square root and cube root of a number by using prime factorization concept. And we are going to solve questions in exercise 1.2 and 1.3 of this book, which I recommend, which is called Secondary Basic Mathematics Book 2, which you can order right now in our library. You can visit Tanzania Online Ordinary Library, where you can order this book with only a price of 17,000 Tanzania shillings, and you can order a package of books that can help you to learn and understand ordinary basic mathematics from 1 to Form 4. This is the package. So just visit there and send a message through this telephone number 0759745331, and then we'll make a call and then give you more details about how you can order this bunch of books so that you can have a department of basic mathematics at your home place. Ladies and gentlemen, before I end these sessions, I would like to remind you, in Tanzania, I would just say that mathematics is the national disease. And I would like to say that is not true. Mathematics is not a national disease. It's a great subject, which is cross-cutting subjects, which can help us to solve real-life problems. May God bless you. Keep enjoying the beauty of basic mathematics and think beyond the classroom instructions. See you in the next session. This is Olenjolai from Tanzania.